Right now, you believe things move. It feels so obvious that you've probably never questioned it. You walk across a room, a car passes by, a ball falls from your hand to the ground. Everything around you seems to be in constant motion, flowing smoothly from one moment to the next. It's not just something you observe, it's something you trust. Motion feels like one of the most fundamental truths about reality. But pause for a second and really look at what you're assuming. When you say something moves, what do you actually mean? That it changes position over time? That it travels from one place to another? That there is a continuous path connecting where it was to where it is now? Because here's the uncomfortable part. That picture, the one your mind automatically creates, might not exist outside your perception. What feels like a smooth journey could be something entirely different at a deeper level. And this is where things start to break, because physics, the most precise framework we have for describing reality, does not actually describe motion the way you think it does. In fact, when you look closely enough, the idea of motion as a continuous flowing process begins to fall apart. So now you're left with a strange question. If motion doesn't exist in the way it seems to, what is actually happening? For most of history, the idea of motion felt simple. An object starts in one place, time passes, and it ends up somewhere else. That's the picture you've always carried without thinking. A car drives down the road, a leaf falls from a tree, your hand reaches for something, everything seems to move smoothly through space as time flows forward. But this simple picture hides a strange problem, one that people noticed thousands of years ago and never fully resolved. Imagine you want to walk across a room. Before you can reach the other side, you must first reach the halfway point. That seems reasonable. But before you reach that halfway point, you must reach half of that distance. And before that, half again. This continues endlessly, dividing the journey into smaller and smaller steps. So here's the paradox. If there are infinitely many steps you must complete before reaching your destination, how do you ever get there at all? Each step takes time, no matter how small, add up infinitely many steps, and it seems like motion should take forever. You should never arrive anywhere, and yet you clearly do. You walk across the room without getting stuck halfway forever, so something doesn't add up. Either motion works in a way we don't understand, or the way we imagine motion is fundamentally flawed. For centuries, we chose the easier answer. We trusted our senses and ignored the contradiction. We told ourselves that motion is real, that the math must somehow work out, and we moved on. But that quiet inconsistency never disappeared. It was waiting, unresolved, for physics to dig deeper and uncover what we had been missing all along. For a long time, we believed time was simple. It flowed the same way for everyone, everywhere, like an invisible river carrying everything forward. Seconds ticked at the same rate whether you were standing still or racing across the planet. And because time felt stable, motion felt stable too. If something changed position over time, then motion must be real. It seemed unquestionable. But then physics forced us to confront something deeply unsettling. Time does not behave the way you think it does. According to Einstein's theory of relativity, time is not universal. It does not pass at the same rate for everyone. Two people moving at different speeds or experiencing different gravitational conditions will measure time differently. One clock can literally tick slower than another, not because it is broken, but because reality itself allows it. Imagine that for a moment, two observers watching the same event can disagree on how much time has passed, and both can be correct. There is no single, shared timeline that everything follows. Time stretches, compresses, and shifts depending on perspective. Now think about what motion actually depends on. Motion is defined as a change in position over time. But if time itself is not fixed, then motion cannot be fixed either. The same object can appear to move differently depending on who is observing it and how they are moving. There is no absolute measure, no universal reference that everyone agrees on. This is the deeper crack in the idea of motion. Without a universal time, motion loses its foundation. It stops being something objective and becomes something relative, tied to the observer rather than the object itself. And this leaves you with a question that is difficult to ignore. If time isn't real in the way you assumed, if it bends and shifts depending on perspective, then what exactly are you measuring when you say something is moving? Think about the last time you sat in a moving train. Inside, everything felt still. The seat beneath you was steady. The person across from you wasn't drifting away. If you closed your eyes, you could almost believe you weren't moving at all. But look out the window and the world rushes past. Trees blur, buildings slide backward. The ground seems to pull away beneath you. So which is true? Are you moving or are you at rest? The answer depends entirely on where you're looking from. To someone standing on the platform, you are clearly moving at high speed. To you inside the train, it's the outside world that appears to be moving. Both perspectives are valid. Neither is more correct than the other. This is not a trick of perception. It is a fundamental feature of reality. And this leads to a deeper realization. Motion is not something an object simply has. It is something defined in relation to something else. You are not moving by yourself. You are only moving relative to the ground, the tracks, the planet. Change the reference point, and the motion changes with it. Now push that idea further. The Earth is spinning, orbiting the Sun. The Sun is moving through the galaxy. The galaxy itself is drifting through space. From one perspective, you are sitting still. From another, you are moving at thousands of kilometers per second. Which one is the real motion? There isn't one. There is no absolute motion hiding underneath all these perspectives. There is no final frame where you can say, this is the true movement and everything else is an illusion. And that creates a strange kind of trap. If every motion is only defined relative to something else, then nothing is truly moving on its own. Movement becomes a comparison, not a property. And once you see that, the idea of motion begins to lose the solidity it once had. Up to this point, you could still hold on to the idea that motion exists in some deeper, more complicated way. Maybe it's relative, maybe it depends on time, but objects still travel from one place to another. That intuition feels hard to let go of. But this is exactly where quantum mechanics removes the last piece of support. At the quantum level, particles do not behave like tiny objects moving along paths. They don't follow smooth trajectories through space. In fact, the idea of a path itself begins to disappear. According to quantum mechanics, a particle does not have a definite position and a definite momentum at the same time. This isn't because our measurements are limited. It's because those properties do not simultaneously exist in a precise way. So what does that mean for motion? If you cannot say exactly where something is and how it is moving at the same time, then you cannot describe a continuous journey from one point to another. There is no clear line connecting where a particle was to where it is now. The very concept of a trajectory, something traveling smoothly through space, breaks down. Instead, what you get is something far stranger. A particle is described by a spread of probabilities. It doesn't occupy a single location. It exists as a range of possibilities, a cloud of potential outcomes. When you measure it, you don't track its motion. You simply find it somewhere within that distribution. And between measurements, there is no hidden path waiting to be discovered. The mathematics does not describe a particle moving step by step through space. It describes how the probabilities change over time. The focus shifts completely, not from where the particle is going, but from how likely it is to appear in different places. This leads to a conclusion that feels almost impossible to accept. At the fundamental level, nothing travels from point A to point B. What changes is not position through motion, but the distribution of possibilities themselves. And what you perceive as movement is just the pattern those probabilities create when they are observed. At this point, the idea of motion starts to feel less like a fundamental feature of reality and more like a story we've been telling ourselves. So if nothing is truly moving, what is actually happening? The answer is both simpler and more unsettling than you might expect. Instead of objects traveling through space, reality may be something closer to a sequence of states. One configuration of the universe exists, then another, each one slightly different from the last, not connected by a continuous path, but by a kind of update, like one version replacing the previous one. Think about a video for a moment. When you watch it, you see smooth motion. A person walks, a car drives, a bird flies across the sky. But if you pause the video and look closely, there is no motion inside any single frame. Each frame is just a static image. The movement you experience comes from your brain stitching those frames together into a continuous story. Now imagine that reality itself works in a similar way. not as a flowing process, but as a rapid sequence of snapshots, each one complete in itself. What you interpret as motion is simply the difference between one snapshot and the next. Your mind fills in the gaps, creating the illusion of continuity. This is the shift that changes everything. Motion is not something that exists out there in the world. It is something constructed in here, inside your perception, a way your brain organizes change so it feels smooth and meaningful. And once you see it like this, something clicks. The universe is not moving from place to place. It is updating from state to state. What you call motion is just your experience of that unfolding, a translation of discrete changes into a seamless flow that never actually exists. Now take that idea and turn it toward yourself, because it's one thing to say objects don't move. It's something else entirely to realize that includes you. You feel like you're moving through space right now. Your body shifts, your hands move, your eyes scan the world. It feels continuous, stable, like a journey unfolding from moment to moment. But if everything you've just seen is true, then that feeling is not what's actually happening. Your body is not traveling through space in the way you imagine. It is not a fixed thing moving along a path. Instead, it is a constantly changing state, updating over and over again. Every fraction of a second, the configuration that you call you is slightly different. Not because something inside you is moving, but because the entire pattern is being redefined. And yet, you don't experience it that way. You experience continuity. You feel like the same person who was here a moment ago, just slightly further along. But that sense of continuity is something your mind constructs, just like it constructs motion. It connects these changing states into a single story and calls it you. This is where the idea becomes personal. Your identity is not a path through time. It is not something traveling from a beginning to an end. It is a process, unfolding step by step, each moment replacing the last. So when you think about your life as something moving forward, consider a different possibility. You are not moving through time. You are being redefined by it again and again, in ways so seamless that you never notice the change. By now, the pieces start to come together in a way that's hard to ignore. Time is not absolute, position is not absolute, and motion, the thing that seemed so certain at the beginning, no longer has anything solid to stand on. What you once thought was a fundamental feature of reality begins to look more like a projection, a way your mind organizes change into something that feels continuous and real. When you strip it all back, the picture is very different from what you were taught. The universe is not a stage where objects move around in space over time. There is no universal clock guiding everything forward, no fixed backdrop where things travel from one point to another. Instead, what exists is a constant unfolding of states, each one giving way to the next. And in that unfolding, something profound becomes clear. The universe doesn't move, it transforms. What you call motion is simply your experience of that transformation, stitched together into a story that feels smooth and intuitive. This doesn't make reality less real, it makes it deeper. It reveals that what you see is not the fundamental layer, but a translation shaped by perception. And when you finally let that sink in, one idea remains, simple but unsettling. Nothing is moving, because everything is becoming.